Hello everyone, welcome to the video for CHEMBLAST. In this video, we're going to discuss question for chapter 6 chemical equilibrium, specifically question number 1. Question 1a, write the equilibrium constant Kc and Kp for the following chemical equations. We have NH4NO3 solid in equilibrium with N2O gas plus 2H2O gas. On K, it must be product over reactant, but for Kc specifically, it is concentration, where in Kc we will only write down the species in gas and aqueous state. In this equation, we only have gas in the product side and the reactant we have the solid. So in Kc we will not write down the reactant here. So Kc will be N2O and H2O to the power of 2. 2 here is because we have 2 moles of H2O. N2O here is actually to the power of 1. Since here we have 1 mole, but then number 1 you don't have to write. So that's for Kc. For Kp, it is for pressure. Pressure is only applicable for gas state. So again, in this case for Kp, we will only write down the product side here, since both of this is in gaseous state, while the reactant is in solid. So to write down the Kp, it is Kp, pressure of N2O and the pressure of H2O. Again, don't forget, since H2O here, you got 2 mole at the front, so it will become to the power of 2. So here you will get 1 mark for Kc and another 1 mark for Kp. Question 2 Roman, we have AgCl solid in equilibrium with Ag plus aqueous and Cl minus aqueous. For the Kc concentration, it must be gas and aqueous state only. So for this equation, the reactant is in solid, so we don't have to write. But then we have Ag plus aqueous and Cl minus aqueous. Here we will include it in the Kc itself. So Kc will be equal to Ag plus and Cl minus. Since here is 1 mole of Cl minus, 1 mole of Ag plus, again number 1, it is not compulsory for you to write it down. Okay, next is for the Kp. Kp is only applicable for gas state. So in this equation, we don't have any of the gaseous element. So Kp here is not applicable since there is no gas present. Okay, so either you can write down this one, or you can also write down Kp is equal to 1. So here you will get 1 mark for Kc and 1 mark for Kp. Question 3 Roman, we have 2Cl2 gas plus 2H2O gas in equilibrium with 4HCl gas plus O2 gas. For the Kc, it must include the gas and aqueous state. When you look on the equation, all of the species is in gaseous state. So it means that all of it will be written in the Kc. So Kc will be HCl to the power of 4 and O2 to the power of 4 here because we have 4 mole of HCl over Cl2 to the power of 2 and H2O to the power of 2. This is because both of our reactants have 2 mole in front of the species. So that's for Kc. Kp, for the pressure, again all of it must only include the gas state. Since all of this is in gaseous state, so all of the species must be written in Kp. So the Kp is pressure of HCl to the power of 4 and pressure of 2 divided by pressure Cl2 to the power of 2 and pressure of H2O to the power of 2. Again, you will get 1 mark each for Kc, 1 mark for Kp. Question 1b, an equilibrium mixture contains 2 moles of bromine, 1.25 moles of hydrogen and 0.5 moles of hydrogen bromide in a 4 dm³ container. Calculate Kc for the reaction below. Okay, so how to answer the question? So the question asks to calculate the Kc for the reaction below. So what is Kc? Kc stands for the concentration and K is the equilibrium constant, must be the product over reactant. For concentration only for gas and aqueous state. And for this equation itself, we have Kc is equal to HBr to the power of 2 divided by H2 and Br2. So that is the Kc for the equation itself. So now we have to calculate the value of Kc. Okay, so C stands for the concentration. K it means that in equilibrium. So the question mentioned at equilibrium mixture. Okay, so it means that the value is in equilibrium. But then again, we want to calculate the concentration. So how to calculate the concentration? Okay, we have to use the formula M, molarity equal to N, number of mole divided by volume. So now we take out information from the question, which is the number of mole of Br2, H2 as well as HBr. So now we know the number of mole of each of the species, and then we also know the volume, which is 4 dm cube, which is the same as 4 liter. Okay, so now we can calculate straight away the value of molarity of each species. So now we're going to continue for the calculation for the concentration. So for Br2, to divide by 4, you will get 0.5 molar. For H2, 1.25 divided by 4, you get 0.3125 molar. While for HBr, you get 0.5 divided by 4 equal to 0.125 molar. Okay, so N divided by V, okay, remember number of mole, volume must be in liter, or it could also, liter could be the same as dm cube. Once you have determined the concentration of all the species, and then you have to substitute the value into the Kc. Make sure you substitute the correct one. So once you substitute the value, you will get the Kc to be 0.1. Again, equilibrium constant has no meaning. Okay, so for the 2 marks, where will you get the mark? The first mark here is when you get all the concentration correct, and the second mark is when you write down the value to be the 0.1. Okay, so that's for question 1b. The last question, question 1c, at 900 degrees Celsius, carbon reacts with carbon dioxide to produce carbon monoxide according to the following equation. Given that the Kc for the reaction is 0.014, determine the value of Kp for the above reaction at the same temperature. Question asks to determine the value of Kp. So first write down the Kp itself. So the Kp here, again, only for gaseous state. So Kp is the pressure of CO to the power of 2, because here we have 2 moles, divided by the pressure of CO2. Okay, but then when we want to calculate the value of Kp, we don't have any value for the pressure here. So how to determine the Kp given that we have Kc? So tips given here is that we have to find the delta N and use the equation Kp is equal to Kc RT delta N. Okay, since we do not have any value of the pressure of the species, then we have to use this formula. Okay, because it relates the Kp and Kc, where the Kc is given in the question itself. So Kc is 0.014. So delta N is the difference in mole product minus mole reactant. Again, the mole product minus mole reactant only for the gaseous state here. So the product is 2 mole, and the reactant, we will not include the carbon solid, we will only include the CO2 gas. So it will be 2 minus 1, so delta N we will get 1. Okay, for the R, as R is a gas constant, which is 0.08206. Okay, and T is the temperature. From the question, we know that it is in 900 degrees Celsius. But then if you refer back to the unit of R, the unit is in Kelvin, per Kelvin. So the temperature must be changed to Kelvin. So you're going to add plus 273.15, hence you will get 1173.15 Kelvin. Now you know all the values here, then you can use this formula again to calculate the Kp. So Kp equal to KCRT delta N. Make sure you substitute correctly, and then you will get the value of Kp to be 1.35. This question will give you 2 marks. Okay, 2 marks here. 1 mark is your formula of your substitution, and the second mark is for the value of Kp. So that is all the video for discussing question for chapter 6 chemical equilibrium question 1.